Projectile motion example number 3. Problems like this are known as package drop problems, as the object that is the projectile is dropped from some raised height that is also in motion. In this instance, we know that our bomb has been dropped from 4,000 meters. That will be our delta y. We also know that the plane was traveling at 90 meters per second, so therefore that speed will be imparted to our projectile. The first question asks us to find out how long the projectile will be in the air. To find that, we use our delta y is equal to 1/2 gt squared equation rearranged to find t. Once we've substituted in all of our information, we end up with, in the top portion of our fraction, 2 times 4,000 meters divided by 10 meters per second squared in the denominator, all underneath the square root bracket. The numerator of the fraction then becomes 8,000 meters divided by 10 meters per second squared, which will give us a square root of, or I should say the square root of 800 seconds squared. That will give us an actual value of 28.28 seconds. The second question asks us what horizontal distance the bomb will cover before it hits the ground. Well, by again using our horizontal velocity equation, we can find delta x is equal to Vx times t. We know that our bomb is traveling at a horizontal velocity of 90 meters per second, and we just solved for the time of 28.28 seconds. So by multiplying those two together, we can find the total distance traveled horizontally by the bomb before it hits the ground. That ends up being a distance of 2,545.2 meters. The third question asks us to find out how far the bomb will have fallen in 15 seconds. To do this, all you need to do is plug in 15 seconds into your vertical distance equation, which is delta y is equal to 1/2 gt squared. Once that has all been plugged in, you'll actually come to the point where delta y is equal to 1,125 meters. So in 15 seconds, that's how far the object would have fallen. The final question in the problem asks us to find the resultant velocity of the bomb at 25 seconds. We know that the horizontal velocity of our projectile will not change, therefore Vx is 90 meters per second. We do know, however, that our vertical velocity is changing, so Vy is equal to g times t. So we take our 10 meters per second squared and multiply it by the time in the question of 25 seconds. That lets us know that we have a vertical velocity at 25 seconds of 250 meters per second. To find the resultant velocity, we again use a variation of the Pythagorean theorem, where Vx is replacing A and Vy replaces B, while Vr, or the resultant velocity, replaces C. Once we have that written out, we plug in our information, or Vx is equal to 90 meters per second, and we square that, plus our Vy of 250 meters per second, which will also be squared. Upon plugging in the numbers, we end up having 8,100 meters squared per second squared plus 62,500 meters squared per second squared. When added together, that will give us 70,600 meters squared per second squared underneath our square root. In taking the square root of that, we end up with a resultant velocity of 265.71 meters per second. Again, please make sure that if you have questions, you get online and you post them.